Hello, my name is Carl Cook, and I'm President and Chief Technical Officer of IntelliDynamics, a division of Biocom Systems. And this is the first session of a series of technical sessions on the Intellect 3 architecture. And in this first session, we'll be talking about data. It's management and data virtualization that we find within the Intellect architecture. Now, most everybody has a pyramid of sorts, so I decided to create one myself. And basically what we're going to be talking about in these sessions is moving up from the bottom, up the pyramid, from data access to data virtualization, data validation, cleansing and conversion, and then causality, beginning the analysis of the data, modeling, prediction, and optimization, as we strive towards the top of the pyramid, which is a benefit to the organization and all its customers. Now, with any pyramid, what we really need to do is to plan from the top down in developing a solution that benefits the organization. So what is the objective that the organization is seeking? And then go down through that process of identifying what needs to be optimized, and that should be based on what kind of information and where is the data, etc. So you want to do top-down planning and bottom-up implementation. So to build the solution, you want to go, once you have your plan, you want to go from the physical stores up through data, understanding, anticipation, and taking action to deliver the benefit. So, in this series, we'll talk about the bottom of the pyramid, data access and data virtualization. Now, data access is strictly accessing the data. And data in your organization can be found all sorts of places. And therefore, within the Intellect architecture, we support all sorts of data sources. Whether that be text files or Excel workbooks or SQL Server, Oracle, OSI Soft Pi, which is a real-time data historian, GEI historian, and our own Intellect 3 historian. All of those are real-time types of data solutions, storage facilities. OPC, which is OLE for process control, so we can talk to process control systems in manufacturing and oil and gas and those types of environments, as well as proprietary financial data streams in that sector, including both real-time and end-of-day historical data. And in some cases we talk to medical devices, etc. And so we start getting into the miscellanea at the bottom of that. And that's because we have a modular plug-in capability. We can add more data sources as we see fit and as you need. We also support accessing many fundamental and custom data types. So within those data sources, you might find text, which might be a web page, it might be just a word, it might be numeric data, it might be events that are occurring, which is something that has a start time and an end time, and it has a meaning within a context of something happened. And quotes in the financial world. So there's a whole variety of different fundamental and custom data types that need to be and are supported. We access the data through something called the data manager, which is just that generic blue block in the diagram. And that is actually a data access factory. In other words, it will assemble various tasks to access data in those different repositories. And we can go get that data asynchronously and simultaneously in parallel across multiple different kinds of data sources all at the same time. So if there's a data request and that data happens to be residing in an Excel workbook, and some of it resides in OSI Soft Pi, and some of it is in an Oracle database someplace, no problem. We can go and access those different data sources simultaneously in parallel and asynchronously. Then we pull that data together and we can synchronize it. And In some cases, the data may be stored according to lot numbers in manufacturing, or an order number, or a customer ID, or oftentimes, 90% of the time, or greater, it's associated with a date timestamp. It's a time series, and most everything is based in time, even if it's an order. It has an order date and date fulfilled, and etc. There's a sequence of events through time. So we, first and foremost, typically synchronize data based on date timestamps. So there may be in the Excel file and in Pi and in Oracle, there's maybe a date time column, and we can take the data and we can actually assemble it and synchronize it based on date time or other key fields. And we have 4 different kinds of data synchronization methods, and many of which you can find in something like SQL. But there's one that's special, which is all from both. That is to say, if you get data from one source and data from another source, you can actually join them, even though none of the index key fields match in a date time scenario. So that if the date times match, then those records are put onto the same line, and if they don't match, then they're interwoven through time as you go through the data set. So then we can synchronize data from these multiple sources using whatever index key fields are appropriate. Then we also put the data manager puts the data into common formats, whether that's arrays or lists or whatever makes sense, because each data set may have its own structure and type. So for example, Pi may give you back tags with a history associated with those. SQL may give you a data table. OPC may actually give you a hierarchical structure of tags in various unit operation contexts. So we can then take those different structures that are found in the data sources and put them into a common format for downstream processing within Intellect. Now, data virtualization, which is the next layer above data access, is very powerful, and it's very useful, and it's a big buzzword in the industry today. And within the context of Intellect 3, we call it CVA, Context Variable Alias. And it enables you to define access to particular variables that are found down in the data sources just one time, and then you can reuse that data access definition over and over and over transparently. Transparent to both the system and the user. That means the user can say, give me this variable, and whether or not the user even knows where it is, the system can go and says, oh, that is in SQL server, and that is in this table, and I log in using this user ID and password, and etc. So that just gets defined once, and the system automatically just responds to the data request and goes and gets the data transparently. And after a while, the user doesn't even care where the data is anymore. In fact, the user is thinking in context of, give me this variable, and then I don't care where it is. That concept isolates variables from sources, so that if it's the data is sitting in SQL Server initially and it gets moved over to Oracle, or it gets moved into OSI Soft Pi system or some other data source, from an administrative standpoint, the sources can be switched behind the scenes and the user doesn't care. So now you have mobility of where you store pieces of information, and it doesn't matter anymore. You just do whatever is appropriate for your IT architecture and environment, and you can change it dynamically, and the user doesn't even realize it. It also isolates the name from sources. In other words, you could have different aliases for the same variable, and we'll talk about that a little bit later in the CVA variable definitions. The variables can be defined in the terms of the user, not in the terms of the data source. So in a data source, it may have some cryptic name, but to the user, it's some common name. It also enables alternative sources, or what we call surrogates. That is to say that if I'm getting data from Pi and all of a sudden the Pi system goes down, the system can automatically say, oh look, there is an alternative source for this variable over in OPC. I'm going to switch over to OPC and bring the values directly from the control system rather than from the control system to Pi to the user. So with surrogates, that enables alternate sources in case one source is unavailable or has been removed. Also within the data virtualization layer, we specify the units of measure and various kinds of ranges and validation rules that apply to the data. So there may be a range that the value should be between 0 and 10,000, and anything outside of that range is obviously invalid. If the value, while the process is operating, needs to be between 1,000 and 5,000, then something abnormal is happening. So we have something called an operating range and a base range for validity checking, and you can have all sorts of ranges applied in there. Or it could include optimization range, which says that if you're going to manipulate this variable, you have to do it within this range, which may be even more constrained. We also support very generalized types, including numeric, text, alerts, events, etc. in the data virtualization layer. And you can define that this variable is a floating point numeric, or it's a text variable, or it's an event. It's something that can be controlled. It's something that is manipulated, but you can't control it. This is something that is just comes as it is. It's an effect of the process that you're running. And then we can place variables into contexts, which is a very useful thing, and we'll spend the next slide on that. So what's a context? Well, a context is a framework that where the variable is used within the real world. The best way to describe it is according to the tree on the right-hand side, where it says my company. And my company might have 2 manufacturing plants, one in New Mexico and one in Georgia. And in the Georgia plant, there's 3 production lines. Those are all contexts. And variables such as oven temperature, fan inlet pressure, and fan speed could be put into the context of production line 1. Production line 2 may also have the same variables of the same meaning. Although physically they're different variables with different values, from a meaning standpoint, they are very, very similar to each other. So this puts the variables within a structure and a context. So that enables you to locate a particular variable quite easily. If you wanted the oven temperature for the production line 1 in the Georgia plant, you know right where to go look for it. It also enables you to easily locate and use all variables for a context. If you want to find all information about production line 1, you can just go to it, and there they are. It also gives meaning to variables, in that you, through the alias standpoint, you can rename something that's cryptic that might be in a database someplace like TT33834B.PV, which doesn't have a whole lot of meaning, but that's actually oven temperature on production line 1. So you can, within the context, assign a variable with its useful name instead of having to deal with all these very cryptic types of tag identifiers, as it's called in the process industries. It also gives variables meanings across contexts, which is a very important thing, in that variables of the same meaning can be in different contexts. So oven temperature for production line 1 is also found oven temperature in production line 2 and in production line 3. So, and those all have the same meaning assigned to them behind the scenes. Even though they're different variables on different production lines, they all have similar types of roles and characteristics within your operations. This gives the ability to create solutions for one context and switch them across contexts. So let's say that you create a data access and data handling and a modeling and prediction type of solution for production line 1, which uses oven temperature, fan inlet pressure, and fan speed. You can click on production line 2, right click and say change context, and all those variables get remapped to the appropriate ones for production line 2, and then literally just push a button to rebuild a model for production line 2. And now you have taken a fairly sophisticated solution for in one context and just right clicked and switched it to a different context, and by pushing the go button fit those models specifically to production line 2, and then move on to production line 3. So there's a large productivity gain if there's similarities between meanings of variables across different contexts. So in oil and gas, for example, there may be a company may have thousands of wells, and it's easy to replicate across different wells based on create the solution once and then clone it across multiple contexts. It also enables the system or the user to evaluate the similarities and differences across contexts. So by analyzing production line 1, 2, and 3, not only can you find out the relationship between oven temperature and, say, cookie softness for production line 1, but in general, across all production lines, how does oven temperature, as a general rule of thumb, apply to cookie softness? And that information and knowledge and understanding then can be applied in different contexts and summarized across all contexts. And you can also get all the variables of a particular meaning from all contexts. So that if you said, I would like to take a look at all the oven temperatures, you can click on oven temperature and right click and say, give me all the oven temperatures for all the production lines. And it'll pull them all up, and then you can do comparative analysis of the same meaning variable across multiple contexts. So this is a very powerful concept. I avoid using the word powerful very often. We all get very tired of it. Everybody's saying, "Oh, this is the most powerful I get kind of tired of it. But this is truly powerful in the sense that you can do a lot of work with very little effort. That by defining a solution once and replicating it very easily across multiple contexts, you have a large impact with very little effort. And that's kind of the definition of power. So this concludes the data access and virtualization brief for the Intellect 3 architecture. While this has been at a conceptual level, I haven't shown any product screens or anything like that. This is real, this is implemented, this is running around the world 24/7 as we speak. Numbers are being processed and generated, and this is existing technology. This is not just concepts. In the next presentation, then we'll move up the stack to validation, cleansing, and conversion, which is an important part of any data-driven type of solution. That the data, not only do you need the data and have an easy way to access it, but now you also need to make sure that it's of good quality and utility. I thank you very much for your taking the time to watch this video, and please stay tuned for this series of technical briefs, and thank you very much and have a great day.